This video is about the notion of intelligence and how such notions impinge on tests devised to ascertain whether something has intelligence. Intelligence is sometimes taken to be about behaviors. If certain behaviors are present, this is just what it means to be intelligent. But often it's complicated by the ascription of certain capacities taken to underlie behaviors. That is to say, intelligence is constituted of specific capacities, which may or may not produce certain behaviors. The following will try to disentangle, or at the very least lay bare, the competing conceptions of intelligence and how they inform the kinds of tests available and the kinds of tests possible for determining whether or not something is intelligent. Right off the bat, it is worth observing that typically, whether or not something has a particular property, in this case intelligence, obviously has to do in some sense with what that property is. For example, a bird might have the property of being flightless. What it is to be flightless is to lack the capacity of flight, or what might be construed as the ability to sustain movement through the air. Thus, the issue of determining whether something has the property of intelligence hinges on figuring out what that property amounts to. How we test for intelligence depends on what it is. We already know of one test for intelligence, the Turing test. This is a test of behavior. If a system can behave a certain way, namely converse in such a way as to convince its interlocutor that it is human, then this constitutes sufficient grounds for regarding that system as intelligent. Tests of behavior, like the Turing test, are often taken to work on certain implicit assumptions about a relationship between some kinds of behavior and certain cognitive capacities. For example, passing the Turing test requires language production capacities, language processing capacities, and so on, and these in turn are sometimes taken to be suggestive of cognitive capacities like relevance realization, knowledge representation, and perhaps as well, the ability to understand semantic content. Recall that John Searle's Chinese room argument is in part an argument for the case that the Turing test is insufficient as a means for testing machine intelligence because, he claims, the behavior alone is not indicative of certain capacities that Searle regards as necessary for intelligence, namely the capacity of semantic understanding. The debate around the Chinese room thought experiment helps highlight a critical issue. When can we regard behaviors or outputs as indicative of certain cognitive capacities? Does effective natural language processing imply a capacity for knowledge representation? Does making complex calculations imply a capacity for reasoning? Does success in recognition tasks imply a capacity for learning, relevance realization, or confidence weighing? Clearly, the answer depends not just on how we define these outward behaviors like conversing, recognizing, calculating, but also on how we define the capacities alleged to be responsible for them, like knowledge representation, learning, reasoning, and so on. Arguments akin to Searle's might contend that some behaviors are ambiguous about the question of intelligence. They might argue, for example, that effective language use does not imply the possession of intelligent capacities, whatever they might be. Thus, we are potentially in the position of trying to parse the behaviors that do indicate certain capacities from behaviors that might not. We can ask ourselves two related questions. Which capacities are necessary to deem something intelligent, and what do we think constitutes those capacities? When a crow bends a wire to use it to reach for a reward, we might construe that behavior as indicative of capacities like planning, spatial reasoning, and mental scenario building. We can ask ourselves both whether these capacities of planning, spatial reasoning, and mental scenario building indicate intelligence and whether this wire-bending behavior instantiates them. Some take certain behaviors to be instantiations of cognitive capacities. Sometimes, however, one might want to make appeals to underlying mechanisms taken to be responsible for those behaviors. After all, we would be less inclined to regard the crow as planning, reasoning, or mental scenario building if it turned out to be an animatronic bot controlled remotely by a trickster in the bushes. At the same time, we might still say the behavior is intelligent, because it is ultimately produced by the supposedly intelligence-having trickster in the bushes. But the example poses the following question. Is there any condition under which the behavior could be present without the intelligence? What if the crow turned out to be a program set loose on the world, following some prescribed algorithms for wire-bending behavior? Indeed, such questions, perhaps born in part of the recent advances in so-called artificial intelligence technology, have motivated a shift in focus to the possible underlying mechanisms of behavior to probe the question of what intelligence is. One way that these capacities are cashed out is in terms of properties of the brain. Neuroscientists look for connections between certain behaviors taken to be indicative of certain capacities and neuronal activity in the brain. This doesn't mean neuroscientists necessarily think neurons in particular are responsible for intelligence, but more generally that certain properties of the brain give rise to certain capacities. But what kind of properties? Some think the relevant properties are so-called functional properties. Recall Putnam's argument on functionalism that the causal organization, rather than the chemical or biological properties of a system, might be the right stuff to focus on when trying to figure out what minds are. This general thesis is often applied to intelligence as well. We can think of it like the difference between being a kite and being iron. To be a kite is to have certain properties pertaining to what the thing does. It flies into the air, attached to some kind of tether. It can be made of silk or plastic. It can be diamond-shaped or the shape of a dragon. On the other hand, being iron has expressly to do with how many valence electrons the substance has, how it reacts to oxygen and other substances, and so on. If this distinction seems somewhat tenuous to you, you're not alone. A lot of the debate around how to define intelligence, and by extension, how to test for it, gets weighed down by the explanatory expectations associated with defining intelligence. Whether or not we think, for example, that natural language processing implies the capacity to represent knowledge, we can ask, is it the natural language ability or the knowledge representation ability that constitutes an aspect of intelligence? Do we think intelligence or capacities taken to be intelligent are like kites or like iron? Is there a big difference? If something has the capacities, does that mean it has the right functional organization? If it has the behavior, does that mean it has the capacities? And which one matters for calling something intelligent? So, when it comes to testing, we need to be aware of the implicit assumptions that might be baked into a given test. On the one hand, it seems hard to imagine how certain behaviors are possible without certain capacities. Can you have human-like conversation without the capacity for some form of knowledge representation, memory, relevance realization? But what are these capacities anyway? On the other hand, we have reason not to be too hasty in attributing capacities based on behaviors. In your reading by Legg and Hutter, they acknowledge this intuitive hesitation, characterizing the assumption that nothing more than a collection of specific algorithms for answering common IQ test questions seems insufficient for intelligence. But we also need to decide what we mean when we define and describe capacities. Maybe all we mean by, for example, knowledge representation is just the ability to produce a certain behavior. Here is an interesting consideration. Mathematical ability is commonly associated with intelligence. So are games like chess and Go. Being good at these activities is conventionally regarded as a marker of intelligence. But when we consider systems like Deep Blue and AlphaGo, some of us may intuitively balk at ascribing them intelligence. Our intuitions here may have different roots. Maybe we take these programs to have some of the right behaviors, but the wrong capacities for producing those behaviors. Maybe we take the behaviors themselves to be either insufficient on their own or unnecessary and insufficient for qualifying as intelligent. Maybe their abilities would be sufficient were it not for the fact that the way those abilities arise is the wrong kind of thing. Indeed, we may appeal to how Deep Blue and AlphaGo excel at their tasks to defend our intuitions about their level of intelligence. Perhaps they lack the capacities normally attributed to successful chess and Go playing, or perhaps they lack some finer-grained functional mechanisms for producing that behavior. That is to say that maybe we regard their programming as the wrong kind of thing for ascribing intelligence. However, some are content to agree that Deep Blue and AlphaGo are intelligent in a limited sense. That is, some agree that a range of abilities all belong under the umbrella of intelligence, only most of our extant AI systems only succeed in a very narrow set of tasks. Narrow intelligence is sometimes used to describe highly domain-specific or task-specific systems. This avoids some of the quagmires of pinning down an encompassing and exhaustive notion of intelligence, while still admitting of the shortcomings of the intelligence of current systems. The notion of narrow intelligence thus takes behavioral abilities, like chess and Go playing, to be instantiations of intelligence in a limited sense. Narrow intelligence is contrasted with general intelligence. If narrow intelligence is a capitulation to the difficulties of defining intelligence, artificial general intelligence is the consolation. That is, although we can ascribe limited intelligence to systems like Deep Blue, AlphaGo, and maybe even the algorithms responsible for your Facebook feed, it is human-like intelligence that we are really interested in, and this kind of intelligence, if nothing else, is highly general. That is, human beings can use the same suite of cognitive faculties, whatever they may be, to do an enormous range of tasks, and do those tasks in different domains and by different modes and in any manner of environments or contexts. Artificial general intelligence, AGI for short, is often offered as a refinement of the notion of true intelligence, or whatever it is that gives us the intuition that AlphaGo, Facebook feeds, and Deep Blue aren't truly intelligent. This idea of general intelligence, modeled off human beings, is necessarily anthropocentric, because as far as we know, we ourselves are our best example of intelligence from which to work. But this anthropocentrism is worth being aware of nonetheless. For one thing, a significant number of intelligence tests hinge on the use and/or processing of language. It's worth considering whether and how this emphasis on language might influence our conception of intelligence and the tests we devise. Consider that while a host of capacities may be instantiated by effective use of language, like compositionality, context and relevance realization, knowledge representation, and so on, this is not the only way they can arise. Moreover, perhaps these capacities aren't essential to intelligence anyway. Indeed, there's another side to this anthropocentrism about intelligence. That is, it seems as though our expectations for intelligence shift with each technological accomplishment achieved by new AI. In broad strokes, we might charge prevailing opinion with being satisfied that certain behaviors were a good litmus test for intelligence right up until a machine achieved that behavior. We have witnessed a shift in criteria to a finer-grained focus on certain capacities and what constitutes evidence of such capacities, like knowledge representation and planning and relevance realization and so on, it's worthwhile to ask whether this shift is in part motivated by an a priori assumption of human exceptionalism. For what it's worth, my master's supervisor bet me in 2013 that a computer would not be able to successfully play Go. You may have noticed that a lot of what we have covered so far bears a resemblance to the discourse on minds and machines in general. It is important for clarity, however, that if we're going to use different words, we're clear about the differences in meaning they are meant to convey. This is sometimes a troubling issue for discourse on the notion of intelligence, because intelligence itself is propped up on other words that sometimes have unclear meanings. If intelligence refers to a suite of capacities, then those capacities themselves need to be clear. As this video has hopefully shown, these capacities are indeed far from clear. Even the correct mode of description, functional, material, behavioral, is up for debate. Still, we can identify at least two common conflations it's best to avoid. A conflation between intelligence and consciousness, and intelligence and having a mind. As you may remember from week 3, consciousness is a fraught subject with anywhere from 3 to 42 different definitions. Moreover, we need not posit consciousness alongside or as a requirement for intelligence. Most of the capacities picked out in the discourse on intelligence make no comment on consciousness. It is an open question whether consciousness is a condition on the possibility of full general intelligence, but conceptually, we ought to keep them apart until we know better. Maybe consciousness is necessary to produce the capacities we associate with intelligence. Maybe not. What's clear, though, is that given the slipperiness of the notion of consciousness, we do not, and perhaps need not, posit that consciousness itself is a capacity belonging to the category of intelligence until otherwise convinced. Similarly, we don't really know what we mean by having a mind, so it's worth avoiding this conflation for the sake of clarity as well. For one, everyday ascriptions of intelligence do not track with ascriptions of mind. Some things we regard as very unintelligent, we may still regard as having a mind, and likewise, we may wish to attribute, albeit limited, intelligence to things like Deep Blue and AlphaGo, without thereby being committed to attributing them minds. Attempting to get more precise about what we mean by intelligence is the cornerstone of devising tests sensitive to the right things. However, as you can see, the matter is open for debate. Which sorts of tests do you think are best for capturing what it is to be intelligent? And what do you think that says about intelligence more generally?